All right, as requested, we have a focused video just on dealing with graphs of linear equations. So that's what we're going to be doing. If you took home a weekly practice sheet, you will see this first set of questions just asks you to solve each system by graphing. What that really means is that you want to graph both linear equations here on the screen, and you want to see if they intersect, if they have a point of intersection. And if they do, what are the coordinates? What are the coordinates, right? X, comma, y, where those two lines intersect. That is the point where both equations have a solution. Don't worry about that for now. The big one I want you to do is practice graphing linear equations. And we have two options or two chances to try it here. So both of these equations are in slope-intercept form. Slope-intercept form. And I really hope by now that you, when I say that, you think y equals mx plus b. The reason you need to think that is because, the reason it's called slope-intercept form is because if an equation is in this pattern or fits this pattern, we can read right off of it without having to do any math whatsoever what the slope is and what the y-intercept is. All we have to do is literally read those numbers out of the equation, and that tells us how to graph the line. So the slope, right? The slope is always going to be the number right to the left of the x, right? It's always look for the x, look to the left, that's the slope. If there's a negative sign there in front of that number, then it's a negative slope. The y-intercept is always going to be the number all by itself, right here, with either a plus or a minus in front of it. It's going to always be just that separate single number without a variable next to it. And make sure you, again, pay attention whether that is a positive or a negative, because that informs how we graph. So let's start with this first equation right here. We see the number all by itself. We see a -1, right? No variable, just the number, -1. That tells us that the line for that equation is going to cross the y-axis where y is equal to -1. So right there where that pink dot is. From there, we have the slope. The slope is this guy right here. Slope is right here. I need to use pink for that too. Slope is right here. And it's a fraction. Oh no, it's a fraction. Don't be scared of a fraction. Fraction, it just tells us that the slope, or m, is 1/2. What that really means is that rise 1, run 2, right? Or you could say change 1 in the y direction, change 2 in the x direction, and do it in a positive way. This is a positive slope. So we start where we drew our pink circle down on our graph or on our coordinate plane, and we're going to rise 1 unit up, and we're going to run 2 units over. Put our dot right there. Now we have 2 points. 2 points is actually all we need for a line, but we could keep going. We could rise 1 again, run 2, and that's another point. Well, now we have a whole collection of points, right? And if we have a whole collection of points, then we can just draw a line right through them. And so that's our first line. And if you want to get in the habit here, you can label it. You can say this is y equals 1/2 x minus 1. Now let's graph the other line. Well, start with the y-intercept. I see the y-intercept is this number all by itself right here being added on at the end. So the y-intercept is a +1. So I'm going to put a dot right there at the +1, that orange dot right on the coordinate plane. And I'm going to look for the slope. And the slope, again, is this number right in front of the x. And that is 3/2. So that tells us to rise 3 and to run, oops, that's not an R, run 2. So we start right at our y-intercept of a +1, and we rise 1, 2, 3, and then we run 2. We go 1, 2, and we put a dot right there. And that's enough points to graph a line, but if you're not sure, well, we could rise in the opposite direction. We could rise 1, 2, 3 down, and then we could run 1, 2 over, and we could put another dot right there. And once we have our two dots, well, you all know the drill from there. We can connect the two dots using a ruler, hopefully, so we get a nice accurate line. And we have our two lines, and moreover, we actually have our point of intersection, right? Right here, circled in purple, is the point of intersection. And that represents the solution to this equation, right? So that looks to me like we go, that is over, so -2 in the x direction and -2 in the y direction. And just like that, we've graphed the line and we've found the solution to the equation. We'll get more into what that solution means later, but for now, that's the important piece. All right, that's graphing a linear equation. Part 2, if I give you a line, if I give you a graph representing a linear equation, can you turn it into an equation in slope-intercept form? And well, it's exactly as you'd expect. We need to do that. We need two really important pieces of information. We need to know, I need to use a different color than that. We need to know what is the slope and what is the y-intercept. And we just go about finding that. Y-intercept's easy. We look for, well, where does the line intercept, or where does it cross the y-axis? And it does it right at that pink circle right there. It does that at y equals -4. And then we just need to pick the slope. And to find the slope, we just need to pick two places where it's going, where the line is going to kind of neatly intersect at these grid lines. So like right there, right there, right there, right there. And what we're trying to do is figure out, okay, to get from one of those intersection points to another, how much do you need to rise and how much do you need to run? So if I start, I need to make it bigger so you can see it. If I start right at that intersection point and I rise, I go 1, 2, so I know I have to rise 2, and then to get over to my other cross, I have to run 1. So that's my slope. And I would hope that by now you know that we could also just rewrite this as an even 2. And once we have those two pieces of information, once we know that the slope is 2 over 1, or just 2, and the y-intercept is -4, we can write our equation, right? We're going to do that just by pattern matching. We're going to say, we know that slope-intercept form is y equals mx plus b, and we're just going to match the pattern. So y is just y, equal sign, bring that right down. M, well, m stands for the slope, and we said the slope is 2, so bring that down there. X is just x. And then we have plus b. Well, we don't have a plus b. We have a minus b, right? So you can write this two ways. The easiest thing to do would be to say, well, b, just swap out this whole piece, bring it down here, write our y-intercept. Right, there we go. You could also, if you wanted to, don't do this. If you're happy with my initial explanation, then you're good to go. You also could write this. These two expressions mean the same thing. This and this are equivalent expressions. If that just makes it worse, ignore it. Look only at the pink answer. Look only really right here at the pink answer. That's good enough. You can work with that. All right, those are two examples. There are others. There are other harder ones, but this is the core idea. This video should help you either use an equation to graph a line, at least given a slope-intercept form, and over here, take a line or take a graph already and turn that into an equation. If you look at other problems on this paper and you're stuck and you're confused, I want you to come back to this video, see if you can extend your knowledge, see if you can maybe puzzle out what happened. Remember, you're here, you're grading, you're working on this because you want to get better at this. So there's no penalty for getting it wrong. Come in, show me, I will help you. I'll tell you where you made a mistake, if any, or I'll give you a pat on the back. If you got through this video, if you actually watch this video and you come in tomorrow, May 8th, and tell me that, I will give you a piece of candy. In fact, I think actually I'll probably give you 2 pieces of candy, but you'd have to have watched the video to the end. All right, I hope that helped.